We are looking to enhance the Hungry Traveling Snake project from the WiByte Python curriculum available at www.wibyte.in. We have been looking at several enhancements. Now, this video will talk about something quite interesting. Notice when sometimes we play the game, we are sprinkling food all over the playing area, but sometimes it so happens that the foods come very, very close to each other. For example, here or here or here. Now, this is per se not a problem. In fact, the game can go on quite normally with this as well. But nonetheless, it's an interesting problem to think about. Can I somehow make these foods place in this area such that they are all at a certain distance to each other? Now, this is something, like I said, pretty interesting to think about, and that's why I decided to kind of delve on this. Very, very good programming practice and has some really interesting implications as well. Remember previously we had done, placement of food so that it stays away from obstacle. So, that is one thing. We had also done placement of poison so that the poison itself stays away from the food. So really what we are talking of here is a generalization of these ideas where now we are going to extend this whole logic to foods as well. We are going to place these foods so-called smartly so that no two foods are very close to each other. And like I said, pretty interesting this is. Let's look at how we do this. Now, like I said, so far we have been just randomly placing the food items all over the playing area. As a result, sometimes the foods end up being very close to each other, as I just demonstrated. But we can avoid the situation and ensure that every food remains a certain distance from all the other food items. So basically, like kind of around every food, there's an area where no other food appears. And this is quite interesting. Before I move forward, I want to leave you with a food for thought. Uh, how many foods can be placed inside a given area with such a distance constraint? So, for example, we have a given playing area of say 220 by 220, and let's say I want to maintain a distance of 40 around every food item that I'm placing. So, question is how many such food items can be placed, and what would be an optimal, let's say, placement for this? Is a very interesting mathematical, thought that you must think about. Happy to discuss. But for now, let's move forward to the code. In our case, in fact, we have a situation where we want to place foods smartly with respect to the obstacles as well as the other food. So it's assuming that you're doing obstacle as a bonus since we are going to build it from there. So we will make sure that foods are far away from all the obstacles. We have already done this. We have done a while loop to do this job previously. Now we are going to extend this while loop to say, okay, look, how do I make it far away from all the other foods? Now the point to understand is that even if I do not do the obstacles, let's say as a bonus, I can still do this as a bonus because this is, really a nice extension of the same idea. What we will do in this video is that first we'll look at the idea behind placing the foods from each other, away from each other, using a simple while loop, and then we will add the check for obstacles. So in fact, we'll go two first and then one. But like I said, the ideas are quite similar and you can incorporate them in different ways. Now, what is it that we are going to do? Well, think about it. We are going to do this for every food turtle. We are going to generate a turtle like we are doing always. We are going to pick a random position like always. We are going to find the distance from all existing foods. Now, how do I do this? Remember, every food out there is inside a list called list of foods. So all I have to do really is that I'm going to find, okay, if this food is very close to any of those foods, then I need to, go back to step number two, which is to say pick up a random position. So, its placement is not complete yet. I need to do this again. If the distance is more than 40, however, I just go back to step number one, which is to say, okay, for this food, the placement is complete. Let me generate the next food item and do all of this. Now, clearly, this is a situation where I do not know how many times I'm going to repeat something. Here is a candidate. Here's a classic use case for the while loop. And all of this is running inside, a for loop for placing all the turtles, all the food turtles. And you can clearly see that this is generalization of how we made the food stay away from all the obstacles, because there what we did was we just found out that find the distance between the food itself and the obstacle. And apart from that, pretty much it remained the same. How do I do this in code? Well, I'm going to use a similar idea. I'm calling it placement done over here, but a Boolean variable, let's say food placed. I set it to false in the beginning. Notice this is only without obstacles, so there's no obstacle in this code. But here I check for every food. I say, okay, if in the list of foods, once the list of food is let's say starting to fill up, so there's at least one food out there. I see that for every other food, if my distance is less than 40, then I'm not well placed. I break off from this loop and I go to the next placement once again, right? However, if I see that I go through every food in the list, if I end up at the last food, which means I'm at a distance from the last food as well, I can be sure that the placement has been done correctly, because it means that every other food is far from the new food that I'm placing. And of course, if the length of food is 0, I'm the first food, then the placement then becomes true. So really, this while loop is going to do the job for me. And now the question is, how do I do it together with obstacle? In fact, that's quite simple. We will do all of this check only if the obstacle condition is already set. Now remember, the way we figure out that food is far from the obstacle is using this condition. So I'm just going to say, okay, let me just further check for this. Exactly what I was showing you here, this loop will be put inside the if condition here. So now think through this. This will make sure that the food is, number one, away from all the obstacles. Number two, also away from each other. Now, like I said, if you do not implement the obstacle, then you don't have this if condition. Only thing that changes here is really the indentation, but the logic remains exactly the same. So let's just, implement this in the code and, see how this works. So I come back to my code here. Notice the Boolean variable I'm using is called food place. So I just go with that. I'll say, okay, look, if my food is far away from all the obstacles. So, so I generate this. I find out the food is far away from all the obstacles. Previously, I was setting food place to true because that is all I cared for. But now I will ensure that. So I'll say ensure food, say food is away from, say, other foods. And how do I do that? Like I said, every food that's being placed is ending up in this list called list of foods. So I say if len, say, list of, say, foods is greater than 0, that means that there's at least one food out there and I must check. So I run a for loop. So, I say, okay, for other, say, foods. So let's say other food in, say, list of food. So if the list is not empty, I look for other food in the list of foods. And I say that, look, if food dot, say, distance other food is, say, less than 40. So that's my threshold, like we just discussed. If this is the case, then I know that I have not placed it properly because there's some food which is close to my present food. So I just break from the for loop and basically I just go back and pick up a new number once again. On the other hand, if this doesn't happen, so let's say if this doesn't happen, I make sure that, so if this doesn't happen, I check, well, have I checked every food in the list of other foods, in the list of foods? So, well, the way I would know that I've checked every food is that if I've gone through all the foods, now I'm at the other food, which is given by, say, list of foods -1. Because remember, that's the last element on the food. We're indexing from the right side. If this happens, then I know that food placed is, so food placed, sorry, call it food, say, placed is indeed, say, true. And of course, I must be careful here. So this is fine for the, over here I must have an else condition as well. So let me just make sure my indentations are fine. I'm going to also say food placed is equal to, say, true. Now look through this carefully. So I'm saying that, okay, look, if I'm clear from the obstacles, let me check for the other foods. Once I'm checking from the other foods, if it's the first food, I come and set the food place to true, so nothing changes really. For the next foods, I find out the length, because the food has been appended to this list. So I check for the length of, the length of this list. Inside this list, I check for every food. If I find that I've reached the last food without having to break the code, I must have set the fruit correctly. And this is really all I need. I'm going to comment this out because now this whole thing is kind of, correct. Now, if I did not comment this out, then remember, this is, not part of this if else. So I'm not checking for the food being away from each other. I don't want this. So if I do this, really, I should be done and we can see this. Now, when I run this code, notice the foods take a while to place, but every food is at a certain distance from each other. And this looks pretty cool, actually. In fact, we can experiment a bit. Let's say I made this threshold to, say, 100. Now, I expect the foods to spread further out. And indeed, that's exactly what we see. Now, you notice no two foods are coming very close to each other. This is cool. But then this brings out a very interesting question. Given the larger the threshold, the lesser the number of foods that I can place. What is that number that I can place with the given threshold? I won't, I'll be very happy to discuss this with you, but make sure your code is consistent with all of this. In fact, you can leave it at 100 because this is really spreading this whole thing out quite nicely and the game is still converging. Now, if your threshold is very large, also the number of foods is very, very large, then sometimes your game may end up in an infinite loop because the food may not find any place to be, any let's say XY position to be placed at also, but it looks like 100 is fine and we can live with that. If learning programming this way by building activities, thinking through them, enhancing them appeals to you, look at our website www.wibyte.in because we learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.